So let me go here and do this Docker pull Redis. So this is extremely boring work that you are just downloading OS and setting up the VM and setting up all these environment variables. And this is extremely error prone. Hello everyone. Today I'm going to talk about Docker and how Docker containers can help both software engineers as well as DevOps engineer and make their life easier. In fact, if you see a lot of systems today, the way they deploy or ship their system is mostly based on Docker or similar such container application. So it's extremely important for any software engineer or any engineer in the software domain to understand how Docker works or at least the basic of it. So let's quickly get started. So this is how the deployments in the good old days so-called looked like. There were VMs, VM1, VM2, VM3, VM4, VMN, and we used to have system administrators. And then we used to reach out to these system administrators to go ahead and install the list of softwares on these machines. So for example, I would go to Alice and ask, hey, Alice, can you install these lists of software? Can you install Java 8? Can you install this antivirus software? Can you also install the certificates? And by the way, can you also update this particular environment variables? And what she used to do was go into each VM one by one and change the environment variable or install a particular software. And also, if there is some OS upgrade, which is a must, because all the operating systems, they release security upgrades. So in those cases also, she had to go to these VMs one by one and upgrade the OS. So a lot of work for the system administrator and in fact error prone as well. So this is how the old system looked like. Then came the newer system, which solved almost all the problems which were there in the older system. So in the newer system, we moved all the configurations to two files. One was Docker file and the other was Docker compose.yml. And this contained all the information on how the code will be built. Will it be built using Java? Will it be built using Node? Which is specific version of Java? Which is specific version of Node? And then how will it be deployed? What are the environment variables which will be used? What is the host OS which will be used to host the code? So all those things were configured in these two files and then checked into Git and into the same repository where your code lies. So for example, if you have a code where you have all the files present in Git, you just put these two files as well. And then you configure Docker and Docker will take care of all the deployments. So the proper standardization of the deployment will be done and it will be less prone because now the developers as well as the system administrator, they both can commit the code, review the PR and get to a consensus that what will be the configuration of the production systems. Let's quickly talk about what Docker is. Docker is a platform which helps in building, shipping, and deploying your application. And Docker Inc. is a company which has a product called as Docker. And they have images. So whenever you put a configuration, you deploy the thing which you deploy is a Docker image. The Docker image is nothing but a cut down OS and they are very lightweight compared to a full blown VM. In fact, the smallest Docker image can be as less as 5 to 10 MB of Linux. So if you see a Linux operating system, it would be a few GB. But similar OS, similar VM in Docker would be around few MBs, between 5 to 10 MB, because it will not have UI, it will not have a lot of features, and it will use the base for a lot of things. And let's quickly go and see how to install Docker. So installing Docker is pretty straightforward. You go to docker.com and then you can click here and download the installer. Once you are able to download and install the Docker, you can go to the terminal and check for Docker --version. And you can see that Docker is downloaded and installed. There was this one more thing which I was mentioning, that the cut down version of the OS image. So one of the smallest OS image is the Linux Alpine image. So I can do is docker pull Alpine. So it's a Linux based image. And what it will do is that it will quickly download the VM, and then I can run docker run -it /bin/sh. And you can see that I am logged into a Linux machine. And if I open a new terminal, I can actually see Docker images. And you can see the Alpine image which got downloaded. It is just of 7.05 MB. Now let's talk about some of the problem statements which Docker container solves, because the problem statements are important for any technology to exist. So there are three different types of problems which I identified for developers. The first is this Docker image helps in setting up the dev environment. So I'm sure you would be able to relate that whenever someone joins your company or team, setting up the dev environment gets hard. So this particular feature is in a beta stage. I am still waiting for it to be prod ready, but overall the direction is is such that, oh, people in future will be able to set up the dev environment using some configuration file, and people in your team will have the common configuration. It's still there, but it is kind of uncooked, but I'm sure it is going to come in a couple of months or so. The second is that there are various cases, and this one I'm going to show you as well, that there are various cases in which you would want to install some software or some tool in your machine, and then later you delete it. For example, let's say you're working on some project where you need Redis, but you don't need Redis all the time. You need Redis for some time and then uninstall it. Many times, this short term thing is painful, because if you forget to uninstall, or even if you uninstall, the complete cleanup never happens. So in using Docker images, the complete cleanup would actually happen. So if you go ahead and do this Docker pull of Redis, so let me go here and do this Docker pull Redis. So this will essentially pull the Docker image from the Docker hub, and then I can run Redis from here itself. So I can do docker run, and I can give the port P6000 colon 6379, and I can give Redis. So this will essentially launch Redis, and in the new tab, I can connect to Redis. So I can connect to Redis using Redis-CLI -P, which is a port, and I can connect to port number 6000. So I'm able to connect to Redis. So here, if you see the command docker run P6000, so 6000 is the port which I can access to. 6379 is the port which is inside the Docker container. So it's like mapping 6379, which is the default port for Redis, to the outside world, which I gave 6000. I could give 6379 as well. And I did a Docker run Redis. So when I did that, I am able to connect to Redis from my machine. I might as well write the Java code and connect to the Redis and do my development. And when I'm done with all my development, what I need to do is do this Control C, and I can actually Docker container ls. If you see, I have a container with me, and I can do -a to see all the containers. You see there is this one container name as Redis. I can actually delete the container so that nothing related to this Redis is there in my machine. So I can do rm, and I can give the container ID. So once I give this, the Redis will be cleaned up from my machine. I might as well clear the image as well. So I can do Docker images, and I can delete the Redis from image as well. So Docker image rm, and I can give Redis. So okay, it is being used by some other container. So I can do a Docker container rm, and I can give the container ID. So in this way, I will be able to clean up my system from Redis completely. So if I do this, you can see the Redis is deleted from my system. So this is the advantage, that you create a Docker image in your machine, you clone from Docker Hub, and the complete cleanup of the tool can be done. And the third one is also extremely important. It is around, what do you do if a particular software which you want to run is not supported in your OS? So, for example, Microsoft SQL Server. So, Microsoft SQL Server is not supported on Mac, but how do you run it on Mac? Because, for example, you have a dev machine which is on Mac, for example, in this case. So, what you can do is you can download the Docker image of Microsoft SQL Server and then connect to the Microsoft SQL Server from your machine by exposing a port. So I'll come again here, and I will actually, first of all, clone the Docker. So you can see SQL Server is being pulled. And now I can run the SQL Server in this way. Okay, so my container is already in progress. So let me delete the existing container. I have been able to launch the MS SQL Server on Mac. So the command goes like the Docker run -d means it will not be interactive. Then it's name of the image SQL Server test except EULA Y. So whenever you install the MS SQL Server, it asks for yes or no. So you did yes. I gave a password to my system administrator as really strong password 1234. And again, I give the port mapping 1433. That is my port to the VM port. And this is the image which I cloned. So when you run this command, you can actually be able to run the Microsoft SQL Server on Mac. And then you can connect to the Microsoft SQL Server on local. So I have done that here. I can come here and let me click on edit connection. So you can see I am connecting to a local host, and let me copy the password here. Copy. Command. And I can do this connect. And you can see I have been able to connect to the database. So from my Mac machine, which is not yet supported by Microsoft SQL Server, using Docker, I was able to run the Microsoft SQL Server on Mac and then connect to that server. So you see all these use cases, they are extremely helpful for developers to do the day-to-day life get done. Now we'll move on to the Docker for DevOps. This is the primary reason for which Docker became popular. That is, how do you streamline the deployment process? So the same case which we talked earlier, that Alice, who is a QA or developer, she wants to deploy something. And we have Eve, who is a DevOps engineer. And Alice keeps on throwing up the requirement that, hey, can you create a prod server with Java 19 Linux, with the Java home set up properly, with RAM disk, some antivirus running, and create a local user with Anuwork, because she might have such a use case because she needs these things. And The problem which Eve is facing as a DevOps engineer is that it's extremely hard to make sure that you don't make any mistake, you don't miss Java home. And you can say that, hey, why not test it? But again, it just increases the manual intervention. And that's her problem. She's saying that I always forget one or the other server configuration. And the other thing is that now what, sometimes Alice throws up the requirement that can you please set up the same machine for 5 more instances? So the machine which was set by her, she wants 5 more machine, maybe 2 in QA environment, or she wants to do some experiments. So this is extremely boring work that you are just downloading OS and setting up the VM and setting up all these environment variables. And this is extremely error prone. So to solve this, the Docker setup had 2 files, which we talked about earlier, and let's just go through it. So I have this project with me. This project is extremely simple. It's a Spring Boot application, and you can easily create any Spring Boot application. I also have put a README file, so you can clone this repo. I have also put this code in the GitHub as well. So you have this Spring Boot application, public static void main Spring Boot. It has a controller, and this application does almost nothing. It has one health check. The second thing it does is that it connects to Redis, and it gives you the value corresponding to a particular key. So I have a Redis command using which I can get as well as put. It's a simple system where you have a Redis server and you have a Java application, and people are making call to the Redis application to get or put the key and value. So it's a plain simple get input operation being done on Redis using Java application. So it's a fairly simple 3-class application. You can go ahead and see how it works, etc. Not much here. The thing which is interesting here is this one is this Docker file. So using Docker file, you can define how you want to build your application. And you can go into the syntax part and how it is. But overall, if I give you an overall picture, this from gives you the name of the image which you want to download and run. So this is the OS name. So OS is Maven 3.8.6 hyphen Eclipse. So there are various publishers of the OS. So Alpine is one of the smallest and lightweight OS. Then you run some copy command, that is you copy the content of current folder to the OS. Then you change the working directory within the OS. Then actually I did this ls, but yeah, can be removed. But then you run the ambient clean install, you copy the jar file to the correct path, and then you run the command java -jar, the jar file. So this will actually be the definition of the Docker image which would get created. And using Docker Compose, you can run the image. So with the first one, Docker file, you can create the image, and using Docker Compose, again, this also looks very straightforward. You can get into the syntax part, but if you get the idea here that I have created 2 services, one is the backend service and the other is Redis server. Redis server I am taking as Redis. So if I write Redis here, it will automatically get downloaded from the Docker Hub. So Docker Hub is a centralized repo from where it will get downloaded. And there are a bunch of things I have done, like server port being configured 8090. That is, I'll be connecting to the server using 8090. And I created some network and both the application in the same network. So I just need to write Redis-server in my Java application, and I'm able to connect to the Redis server. So quite many complicated things going on, but you can see things. I have been able to configure things from here itself. And now let's run a few commands to compile and create an image. For building the image, the command is docker build. Let me move myself here. Docker build. So this will actually build the image. That's the first command. And the second command is docker Docker Compose, and it takes the parameters Docker compose.yml. And if I run this, it will download the Redis server on the machine, and then the image was already there, and you can see my application is running here. So the Redis application is running here, the Spring Boot application is also running. So both the things are running on the same machine, and I didn't have to download the Redis. And now if I go to my local host, if I want to call some of the APIs, so I expose some of the APIs, local host :8090/health check. So it gives me, I'm running on port 90, and I can give the value as 11. So, and then I can get the value as well. So you can see that, what I'm doing is I'm trying to set and get the value from Redis. So I'm making call to the Java application. Java application is making call to Redis and then getting and setting the value. No rocket science here. It's plain simple API call happening here. You should actually clone the code and understand the code more. But if you see how the things are working, they are running using the Docker services. So using Docker images and Docker containers, we have been able to run the application without actually installing the Redis, or you don't even need to install Java as well. So everything is configured in this Docker file and Docker Compose, and yeah, you are good to go for all your deployments. So for your deployments, you just push this file. You can have code reviews, people can comment on the procedure, and nothing will get missed. So overall, a great method to do your deployments. That's all from my side for this video. In this video, you have seen how Docker images and Docker containers help both developer as well as the DevOps engineer. It makes the life of everyone very easy. You can have a process around how do you deploy your application, do you build your application. And in fact, you don't even have to download a lot of software in your machine and make your machine cluttered. You download the Docker image, do your work, and then just delete the Docker image. So extremely important thing, and I would recommend you to clone the code, clone the repo, and try it yourself so that you can get a taste of how things are working. So that's all from my side for this week. Please like and comment if you really like it. It really makes a difference. Till the next time, bye.